Bismillahirrahmanirrahim. Assalamu alaikum to all students. Hope you all are safe and sound at your homes. I am Ms. Sofia Rahujo and I am a lecturer at Government Girls Degree College, Badin, Sindh, Pakistan. I feel very pleased and thankful to our education authorities to take this step of online education to connect us with you in this pandemic situation. And I hope this situation will pass soon. Dear students, the lecture I delivered to you is about integration, so keep your focus on your learning topic and stay with lecture. Okay students, this is our topic integration and these are the contents of our topic. First we have the introduction. What is integration? Types of integration. Integration by formulas. Integration of exponential functions. Integration by substitution method. Integration of trigonometric functions. Trigonometric substitution. Integration by partial fractions. Definite integrals and area enclosed between curves. So here in this lecture, you all learn these topics with very simple way. So stay here. This is the introduction. Concept of integration is quite old, much older than the concept of differentiation. It was defined as a limiting sum summing up the products of mere of subsections of certain base and the values of a function at points of the corresponding subsections. After the advent of differentiation, it was established that there is a relationship between the two concepts, and the problems of integration can be solved through the use of antiderivatives. Antiderivatives was originally called permittive, but later on the word integral was accepted in place of permittive. Today, integration is known as the reverse process of differentiation. Integration is one of the most applicable branch of mathematics. Okay, here we go to the definition of integration. What is integration? The process of finding the inverse of a derivative is called antiderivative or integration. Dear students, it is very simple to understand the concept of integration. Here you have to focus on just two words, derivative and antiderivative. What is the meaning of derivative? In derivative we take things apart, and in antiderivative we together the things or we sum up the things. In other words, we can say that to combine two or more things in order to become more effective is called integration. If f of x is a differentiable function such that d upon df of x equals to f of x, that is derivative of capital F of x is small f of x. Then we say that antiderivative of small f of x is capital F of x. Symbolically, we write it as integral f of x dx equals to capital F of x. Here you can see that the inverse process of the derivation or inverse process of the integration is again we have the same function. The symbol is called the sign of integration and is used to represent the process of integration. The function f of x is called integrand and dx means that integration is being performed with respect to x. Here we have example. If y equals to f of x equals to x, that means y is the function of f of x equals to x. And when we take the differentiability or when we take the derivative of x, we have the result is 1. And when we take the integration of 1, we have the result x. That means these two functions are inverses or reverses of each other. And here we have the next example. If y equals to f of x equals to x squared, that means we have the function x squared, and when we take the differentiability or derivative of x squared by using the power rule of the derivation, we get 2x. And same, when we take the integration of x squared dx, we have the result x squared upon 2. So both functions are same, but the results are different. But when you take the integration of this 2x, you obviously take or get the result x squared. Types of integration. There are two types of integration. One is indefinite integral and the second is definite integral. Here we define indefinite integral. If capital F of x is integral of the function f of x, then so is capital F of x plus c, where c is any constant. The expression capital F of x plus c is being indefinite due to arbitrary constant which may assume any value is called indefinite integral of small f of x. Thus we write it as sine of integral small f of x dx equals to capital F of x plus c. And here we have the definite integral. If a function f is continuous on a finite closed interval ab, then it is called the definite integral of f over ab and is symbolically written as the sine of integral with ba limits f of x dx. In this case, f is said to be integrable over ab. The numbers a and b are called lower and upper limits of integration. Okay, here we have the integration by formulas. Power rule of integration, and it is integration is equals to sine of integral xn dx shows the power rule of integration, and when we solve it by x n plus 1 divided by n plus 1. Just like the derivation power rule of derivations, we have the power rule of integration. And in derivations, we know that we subtract the power and multiply the power. And in integration, we add the power and we divide the power. And this is called the general power rule of integration. In this rule, we have the function and its derivative. Then we solve it by f of x n plus 1 divided by n plus 1 plus c, comma, n is not equals to minus 1. And this is the integral form of the rational function. When we have the questions like this, we get questions like this, we use this formula, or we use this form to solve these questions. Okay, sine of integral f derivative x divided by f of x dx. That means in here we have the function and its derivative is given. Then we solve it. It's very simple. equals to ln mod f of x plus c, where n is equals to 1 is possible here. Integral of the form integration sine of integral ax plus b over n dx. That means when we have the questions in this form, we use this integral form to solve these questions. And we solve it by ax plus b, we add the power, and we again divide the power with the coefficient of the variable multiplied with this power. Integral of the form integration is equals to sine of integral 1 upon x plus a dx equals to ln mod x plus a plus c, and is not equals to -1. Here you have to know that 1 upon x plus a actually shows the logarithm function. In derivations, when we have the logarithm function ln x or log x, when we take its differentiation, we get 1 upon x. And in this form, 1 upon x is given with integral. So when we solve it, we get ln x. Or if we have the function x plus a, we get ln mod x plus a plus c. Integral of the form integration is equals to sine of integral 1 upon ax plus b dx. That means when we have the questions like this, we use this form or we use this condition to solve these questions. Here we have the problems. Find the antiderivative of the functions with respect to the indicated variables. Problem number 1 is integration radical x dx. We already know this is the sign of integration and this is the function f of x, and dx is the operator. By using power rule of integration, we have xn dx, xn plus 1 n plus 1 plus c, and n is not equals to -1. Problem number 1 is in the condition of power rule of integration. So here we use this rule to solve this question or this problem. So here we have the integration equals to sine of integral radical x dx equals to, okay, when we take the variable x and the value of radical is 1 upon 2, we put, and we know that 1 upon 2 is the value of n. 1 upon 2 is the power of the variable. Okay, and we add plus 1 with this n, and also we divide this 1 upon 2 plus 1 according to the formula. Plus c is the again arbitrary constant because this integral shows the indefinite integral. So we must put the constant here. By simplifying, we get x, again same, 2 under 2 plus 1, we get 3 upon 2. And here we have 2 under 2, 2 plus 1, 3 upon 2, but here it shows the compound fraction and we solve it by 2 upon 3 multiplied by x, 3 upon 2 plus c is the result of given problem radical integral radical dx. Okay, here we have the next problem, problem number 2, and that is Sine of integral x square plus 1 with the exponent 3 upon 2 dx, 2x dx. Here you can see that we have the function and its derivative. So we already know about the condition when we have the function and its derivative, then we use the general power rule of integration, and that is f of x and f derivative x dx, and we solve it by this condition. So here we have integral equals to radical x square plus 1 3 upon 2 and 2x dx. X square plus 1 is f of x. So we put here x square plus 1, and 3 upon 2 is the exponent of the function, so we put 3 upon 2 here, and plus 1 is already given in formula. And here n plus 1, we know that the value of n is 3 upon 2, we put the value of 3 upon 2 plus 1 and plus c constant. So by the simplification we get x square plus 1 is same. When we solve this integer form, we get 1 the 2, 2 plus 3 5, 5 upon 2. And again when we solve this integer form, 2 1 the 2, 2 plus 3 5, 5 upon 2 plus c is same. By more simplification we get, this is again shows the compound fraction, so 5 upon 2 will be 2 upon 5 and multiplied with x square plus 1, 5 upon 2 plus c. This is the required answer, or this is the required condition for the given integral problem. Okay, here we have the problem number 3, and that is sine of integral 3 upon x dx. Here we have the solution. We take the solution of this question by using the integral of the form. Integration is equals to integral derivative of f of x divided by f of x dx equals to ln mod f of x plus c. Here we know that 3 is divided with x. In integrations or in differentiability or in derivatives, we have to integrate the variables, and when any term is multiplied or divided with the variables, we separate them and we take the derivation or integration of the variables. So here 3 is divided with x, that means we separate or we put 3 outside of the integral, and then we have the remaining function is 1 upon x dx. So here we integrate 1 upon x dx. So also you know that f of x is equals to x, and when we find the derivative of f of x, we get 1. So our question is now in the condition of the integral form, which we can use in it to solve. So here integration is same equals to 3 is again same, and when we integral we take the integrand of 1 upon x, we get ln x. Here we put f of x equals to x plus c is the required result for the given integral. Okay, here we have the problem number 4. Integration is equals to sine of integral 2x minus 3 with the exponent 3 upon 2 dx. Here we have the solution of this integral by using the form integral ax plus b with exponent and dx equals to ax plus p n plus 1 divided by an plus 1 plus c and comma n is not equals to minus 1. So here you can see that in the question some coefficient is multiplied with variable x, and that is why we use this form. So here we use this form to take the integration of this function. So here we can solve it by using this form. We have the x plus b equals to 2x minus 3. So we put here 2x minus 3 and we have the exponent 3 upon 2. That means this exponent is the value of n. So we put exponent, the value of n is equals to 3 upon 2. And plus 1 is given in the formula. We put it. Divided by an plus 1. That means the value of n is 3 upon 2. We put it. And plus 1 is again same. The value of a is actually 2, which is multiplied with n, but we write it separate because we know that the 2 is divided with this condition. Then we take the numerator as 1 and we separate this 1 upon 2. Okay, and when we simplify this term, we get 3 upon 2 plus 1 is the integer. We solve it. 2 plus 1, sorry, 2 1 the 2, 2 plus 3, 3 upon 5 upon 2. And when we solve this, we again get the 5 upon 2. But by the compound fraction, we write it as 2 upon 5 multiplied with 2x minus 3, 5 upon 2 plus c. So here 1 upon 2 multiplied with 2 upon 5. Here we cancelled 2 with 2 and we get 1 upon 5. And we have the next term is 2x minus 3, 5 upon 2 plus c. So we have okay, here we have the problem number 5. And that is integration is equals to sine of integral 2 upon 5 minus x dx. And here we have the solution of this integral form. We take the solution of this integral form by using this integral form. So here we have the sine of integral 1 upon x plus a dx equals to ln mod x plus a plus c, and n is not equals to minus 1. So here we have the integral 2 upon 5 minus x dx. First we notice that 2 is divided with the function 5 minus x. So when we take the integration or the derivation of any function, we only take the variables to integrate or to derivative. But when the constant terms multiplied with variables or the constant terms divide with the functions or divide with the variables, we separate them or we put them outside of the integral and we solve the integration or we solve the derivation of the variables only. In this condition, when the constant is multiplied or divide with variables, and we can take the derivations and integrations of constant functions also, but here we separate them. Okay, so the next condition, we can see that in this integral form or in this formula we have the positive x, but in the question we have the negative x. So we change it into positive, and we know that we multiplied complete term with minus, then we get the positive x. So here we multiplied minus with 2, we get minus 2, and 1 is here, and when we multiply minus with 5 we get minus 5, and when we multiply minus with minus x we get positive x dx. So here we change the condition of the question according to the formula. So now we solve it by using this formula. Minus 2 is again same, ln again same, and here we put x minus 5 instead of x plus a, mod plus c is again same. So this is the required solution for the given integral. Okay, the next problem is problem number 6, and that is integration is equals to sine of integral 3 upon 3x minus 7 dx. In the previous we discussed that when we have the integrand and we have the functions like that, when some value, when some constant function is multiplied with variable, then we have to solve them by using this condition. So here this question is related to this condition and we solve it by this. But one thing is more. If we pay attention more to the condition of the question, we can see that here 3x minus 7 is the function f of x, and when we take the derivative of f of x we get 3. So in this question we have the function and its derivative is given. So in integral of the form 3 we have the derivative of the function and function. So we can solve it by using this form. The form is given in the formulas and the form is number 3, and we put this form here, ln mod f of x equals to 3x minus 7 plus c, and this is the required condition for the given integral. Dear students, hope you all have understand these topics well. Our lecture is continued. We'll meet you again the next part of the lecture. Stay blessed and stay connected with my lecture.